I'm waiting for word from my able faculty, Shivangi and Geeta, who organized this conference.
Professor Sudarshan, we can start now. Thank you.
All right, very good. So I'm a great pleasure in welcoming Dr. Somanathan to give a distinguished lecture in the course of the first annual conference. This is our first attempt at having something that is a regular feature and an international conference organized by the Tyndall School of Government and Public Policy. We had yesterday two good speakers, Brahma Mukherjee and my fellow citizen from Kolar Goldfields, Bezwada Wilson of the Safai Karmachari Andolan. We wanted a bit of activism infused into academia. As befits a public policy school, we need to translate what scholars and academics find as evidence to inform policymakers. And that requires a bit of advocacy and activist skills as well. But we're very happy to have Dr. Somanathan with us today. He got his doctorate at Harvard, was at Emory for some time, has been in the Indian Statistical Institute, is on the working group of the Intergovernmental Panel on Climate Change. Just today, I think there's a podcast where he interviews Professor Partha Dasgupta on the Dasgupta report to the United Kingdom government. For some time we had on Dr. Somanathan's recommendation, Ridhima Gupta working with us on our faculty. And we learned about the happy cedar. And every time there's crop burning going on around us on this campus, we think, why on earth is this happy cedar not used more extensively as we anticipated it might do, because the econometric analysis that Som helped Ridhima do showed that it is actually profitable to use it, even though you may have to pay a rent to use the machine. The yield increases somewhat to compensate for the additional cost. But it's not been publicized, I suppose. So it's one of those elements for tackling air pollution that hasn't been fully tested. So we have Dr. Somanathan addressing this problem of air pollution and the use of stoves. So I'd hand over to you, Som, to speak for some time, and then we entertain some comments and questions from the audience. Over to you.
Okay, thank you so much, Sudarshan. It's a great pleasure and it's an honor to be asked to give this talk at your first annual conference. And I'm sure you'll get many excellent and better speakers at your future conferences, and it will all grow. So let me go ahead and just share my screen. Yes, I think that should be okay. So, so today I want to talk about, as you just mentioned, one of the big sources of air pollution, which of course affects you and in Sonepat and us in Delhi quite severely on a seasonal basis. Maybe I should just say a word that it's true that the happy cedar hasn't done as much as we had hoped, but it has actually, its use has expanded a lot. So when Ridhima did a study 10 years ago, it was, they had about 300 machines out in the field. And I believe a couple of years ago, the last data I got, there were 3,000. So there's been a 10-fold increase. I mean, it should be a 100-fold increase to really kind of cover the whole states of Punjab and Haryana. But anyway, I think hopefully it will pick up. So today I want to talk about a different, I am going to talk about air pollution issues, but I'm going to talk about a different source today, which is about basically emissions from cooking by households, use of solid fuels. And so the title of this paper is Electric Stoves as a Solution for Household Air Pollution, Evidence from Rural India. And as you can see, there are a lot of co-authors on this paper. It's been a major data gathering exercise. And I just want to say that we are still analyzing the data, that we're not quite finished writing this paper. But so I'd be very happy to have your comments. Okay, so just some background. Air pollution is the world's largest environmental health problem. It has a very huge impact on mortality in particular. So this paper from 2020 estimates that 5.5 million deaths every year globally from air pollution, with 1.7 million deaths in South Asia alone. And that is 10% of global deaths, basically, the 5.6 million figure. Now, just to give a comparison with COVID, which of course is raging around us. So the global COVID-19 excess mortality in 2020 has been estimated by the WHO to be about 3 million, right? And that puts this figure in perspective. So every year, air pollution is estimated to kill many more people than COVID killed in 2020, right? And hopefully COVID will sort of come under control soon. We're not yet over it. But air pollution, unfortunately, has been with us for decades. And let's hope that we have to therefore do something and hope that we can tackle it more effectively. Now, in developing countries, the major source is from households. So in India, for example, the largest single source of ambient air pollution, by ambient air pollution, I mean outdoor air pollution, is cooking and heating emissions from solid fuels by households. And even in a country like China, which has a per capita GDP about 5 times that of India, it's a much richer country. The transition to modern cooking fuels and heating fuels is much further advanced in China. Even in China, households are the largest single contributor to air pollution-related mortality. And the reason is that even though only a small fraction of households in China cook with these solid fuels, but the exposure is very, very high from these cooking emissions because people are right next to them, next to the source in the kitchen. And so it's a very large contributor to mortality. Now in India, another issue is, apart from health impacts, there are also regional climatic impacts from these residential cooking fires. So they are in India, they are the dominant source of emissions of black carbon. And black carbon is basically just, the unburnt part of the fuel, whether it's coal or wood or, cow dung. It's sort of just charred carbon, right? Almost pure carbon. That's why it's black. And what tends to happen is that some of this carbon gets sort of rises and gets into the upper atmosphere and blows and is carried to the Himalayas, where it then falls on the snow. And when it falls on the snow, it sort of darkens the snow and it basically absorbs heat much more effectively than the white snow. And the recent scientific studies suggest that it's a major contributor to the melting of snow and ice in the Himalayas, right? Which is a matter of huge concern for us in India and our neighboring countries. Now, what about coming to solutions? So there have been since at least the 1970s, so-called improved solid fuel stoves of various kinds and designs have been tried out, but they have failed over time to make much of an impact. And I shall be a little blunt here. Basically, people don't want these stoves, by and large. There are only rare cases where they're adopted consistently. People, when they have them, end up not cooking with them. They don't tend to use them very much. And they mostly don't even work. Okay, so now there are exceptions. There are localized places here and there where they've done some good. But if you look at the big picture and you try to think about scalability and the size of this problem, this is not going to be the answer. That much is now clear. So what are we left with? Basically, LPG and electricity are the only really clean and reliable solutions so far. Now, LPG is the big one, but its access is limited in rural areas and developing countries because it has to be transported. Okay. So about 60% of Indian households in India now have LPG access, which is to say they have a connection, and so they can use LPG. They have a connection, they have a stove, they can use LPG. And this has been basically maybe something like a huge expansion of access thanks to the PMUY, maybe a doubling or something like that. So it's been a really remarkably successful program in the sense of increasing access. But it's still the case that LPG is expensive for poor households, right? Even though there's a subsidy, the subsidy has been scaled back recently because of fiscal issues. So usage is still less than half of what is needed to eliminate household smoke. Okay, so people have the connection, but it's expensive for them to use it consistently. And the second fact is that LPG is not as scalable as electricity, right? Because there's the transport issue. Now, most countries where this problem exists, India is not the only one. It's a big country, but there are many other countries in the same boat. Most lower middle income countries now have universal access to electricity, right? Or they have at least made this a goal, as in many African countries. For example, in Kenya, electricity access, according to IEA figures, rose from 20% in 2013 to 85% in 2019. Although with all of these developing country statistics, you should always be quite cautious and suspicious. So recently I was talking to a Kenyan colleague, and she told me that, look, there are different data sources, and probably the true number of people who actually really have access as opposed to theoretically having access is maybe about 50%. But still, it's a big expansion. Okay, now let's come back to induction stove ownership in India. So the electric induction stoves appeared in the Indian market about 10 years ago, maybe a little longer ago. Essentially because this technology is quite old. It's been around for some decades, and in fact, it has been used in Western countries as cooking ranges, but it's only recently that it's got cheap enough to appear in the Indian market. And it basically, because it got cheap, and at the same time there was a rise in LPG prices, so it got quite popular, it spread quite a bit. So just to give you an idea of the cost, an induction stove with compatible utensils can be bought for about 2,500 rupees. I'm giving you the numbers from the study that I'm going to talk about more extensively soon. And ownership varies very widely across India. So only 1 in 1,000 households in rural UP in 2020 were estimated to have an induction stove, according to the survey done by CEEW. And there's 100 times as many in rural Tamil Nadu. So there's a very big variation in this induction stove ownership. So urban areas also, urban UP, maybe 2.5% of households have induction stoves, and in Tamil Nadu, the figure is more like 17%. There's one caveat here, which is that these surveys, they tend to suffer from non-response bias. And in this case, what that is likely to mean is because richer households are less likely to answer the survey. So it's probably these ownership numbers are probably something of an underestimate. But anyway, they give you some idea of the variability. All right. And the fact that in rural North India, essentially, there are hardly any induction, very few. So still, what's our research question? So our main research question in this paper is, do electric induction stoves really reduce household air pollution substantially? Okay. Now, you might think, well, that's kind of obvious. After all, they're smokeless, so they must, right? But it's not that simple, because there's a very large literature on studying this problem. And what it has been found is that rural people, when they adopt modern cooking technologies, typically stack these modern technologies onto traditional cooking so that air pollution continues. So they keep their chula, and they will also have the LPG or the induction stove or both. Okay. And so there's been a lot of skepticism among researchers as to whether these new technologies will really do very much to reduce pollution. Now, the question is, will they be used enough, or will they simply be used for additional cooking, right? For example, because an induction stove is a quick thing, you can turn it on. Maybe all that it will be used for is to heat up leftovers, and people can have a third meal instead of just 2 meals a day, that kind of thing. So it may not be used really for mainstream cooking. And if they are used for mainstream cooking, maybe they will just substitute for expensive LPG rather than replacing the smoky firewood and dung and so on, which are cheaper after all. So let's see. That's what the study is about. Okay, the second research question here in the study is whether electricity outages reduce induction stove use and increase air pollution. In other words, if we can improve the reliability of the rural power supply, is that a way to reduce air pollution by inducing greater use of induction stoves? Okay, so we answer this question at the intensive margin, looking at increased induction stove use by households that already possess induction stoves. Okay. The extensive margin, which is, households that don't have induction stoves buying them, right, as a result of improved electricity supply, that's very important, obviously, extremely important. But in this paper, we are not going to look at that issue. Okay. We would need a different kind of data to do that. Okay, so what do our data look like? We have data basically every minute in our sample of households for more than 12 months. Okay. One sec. Did I miss something? Yes, I missed this slide. Okay, so what is our sample? We look at 10 villages in the Sultanpur district of UP, which is in central UP. Essentially, we took the help of a company called Dharma Life that sells socially useful products, including induction stoves. We did a telephone survey of the company's customers in 4 districts of UP and found that about 70% of them said that they use their induction stoves for cooking full meals. These were the customers we were interested in, because obviously if they're not using their stoves for cooking meals, then that's not going to do anything for air pollution. So we picked up such households from one district, Sultanpur, and we also studied 16 nearby households without induction stoves. So we have 50 households with induction stoves and 16 without, okay? And the ones without are somewhat poorer on average than the ones with induction stoves, but not very much, I would say. So what kind of data? So in all of these 66 households, we put in the following sensors. We collaborated with Prayas Energy Group in Pune. They have this monitor which basically measures voltage and power supply outages, right? So we have one in every household. Well, no, we have one on every electricity line reaching the households. Then our group, we collaborated, some of our co-authors are engineers in Duke University, and they built this PM 2.5 monitor with a clock and a data logger. And we had an ammeter built so that we could measure whether the induction stoves were actually being used at any given minute. All right. We also did 3 household surveys at the beginning of the study, somewhere in the middle, and then at the end of the study. All right. Okay, so now here is the resulting sample of households for which we have all this data. The primary subsample that we're interested in are those households which own the induction stoves and also have a chula. Okay, so we're, of course, because we're interested in whether the induction stove substitutes for the smoky chula and how much. That's the primary subsample. It's about 45 households roughly. It varies a little bit over the whole year because, you know, they switch between categories a little bit. Mostly it's stable, but 1 or 2 switches here and there. The second comparison sample is placebo subsample, as I call it, households with only clean stoves, that is only induction stoves and LPG without a chula, right? So we don't expect any effect on air pollution in those households because they don't have a smoky pollution source in their kitchens. The second placebo or control subsample is the households without induction stoves, okay? And there were about 15 of those. Okay, so these are the 3 categories. So let me show you some data now. Now these are data from our PM 2.5 sensors in the kitchens of the households. And we also have 2 sensors outdoors in each of the villages in which these households are located, right? So what is this data showing you? It's showing you on the horizontal axis, the time of the day, starting at midnight, 2 a.m., 4 a.m., and so on, all the way through until the end of the day. And it is averaging all the data collected every minute in these 66 households and the outdoor sensors, averaging over 1 year, right? What you see is that the daily pattern here of PM 2.5, by the way, maybe I'm taking for granted that you know what PM 2.5 is. It's a very common measure of air pollution, and it stands for particulate matter with a diameter of less than 2.5 micrometers, okay, per cubic meter of air. So it's a concentration measure of how much kind of smoky particles there are in the air. All right, so you can see here a very clear pattern. There are 2 peaks, one in the morning, one in the evening. And this is true for each type of household. Now, if you look at the purple line, which is the highest peaks, those are households that don't have induction stoves. Okay, they have only chula or they have LPG and chula. Right, and you can see that the PM 2.5 is peaking in the morning on average at over 500, and in the evening at maybe around 350 for that category of households. Okay, the orange ones are a primary subsample. They are the ones who own induction stoves, and they also have a smoky chula. And you can see that on average their peaks are somewhat lower. Okay, and then we have 2 more lines, the brown curve and the green curve, right? The brown curve is the recordings from the outdoor sensors, okay? And you can see that they also show these peaks, of course, much less. Why is that? Well, because what starts in the kitchen doesn't stay in the kitchen, it goes outdoors, obviously, right? So the pollution concentrations between indoors and outdoors, between kitchen and the outer air equilibrate fairly quickly because of diffusion, right? So that's why we see that even the outdoor sensors are showing the same daily pattern. And finally, with the green line, those are the induction stove owning households with LPG, but without a chula. And you can see that those households' pollution concentrations basically track outdoor concentrations, right? So they are not generating any smoke in their kitchens, any significant amount. And therefore, whatever pollution they're experiencing is coming from outdoors. right? Okay. So that's just a descriptive picture. And I want to draw your attention also to that dotted line there, and that is the World Health Organization's guideline for 24-hour maximum average PM 2.5 in any day, right? More than that is considered dangerous. And you can see you never get below that, right, on average over a year. Now, if you look at just a single day rather than the average over the year, it looks much more spiky, right? That smooth curves that you're seeing is because we are averaging over a whole year and over many households. This is data from a single household on a single day. Okay, it's also averaged a little bit instead of showing you the raw 1-minute data and giving you 15-minute moving averages. But you can see a similar pattern, but of course it's much more spiky. This is the kitchen. This is a household that does have a chula. And you can see the blue dotted line is the outdoor concentration in the monitor in that village on that day. Okay. All right. So now here's some data from our electricity monitors, the voltage monitors. And again, we are showing you by time of day, averaged over the whole year, over all the 66, well, actually over all the electricity lines. So for all the households. And this is the percentage of the time on average that electricity is available. And you can see that there's a clear pattern. During the daytime, it's much more less likely that the power is there than at night, right? And anyway, it's very far below 100%, right? So lots of outages, very unreliable electricity supply, okay? That is just, I should say, nothing special to UP about that. It's very common in lots of developing countries. Here you can see a whole data from a bunch of African countries from a paper from a few years ago. And you can see on the right-hand panel, if you look at the reliable connection, the percent of households with a reliable connection in various African cities, you can see that again is far below 100%. Okay, so this sort of unreliable electricity supply is a common problem in developing countries. Okay, now let us turn to our results. First, let me just show you what is obvious. Okay, so this is the effective electricity measured as the share of the hour that it is available on induction stove use, measured as the share of the hour that a stove is used. Okay, and we're going to show you that for each hour of the day. So there's a regression equation here, which is the induction use share on the left in household H on electricity line L in season J in hour T. Okay, and then we have some fixed effects, and the main coefficients of interest are these CJs, which are the electricity shares. Okay. And so, as I said, we have a whole bunch of fixed effects. And so the main thing that you need to keep in mind is that what we're doing is we're comparing the same households for each hour of the day across different days. So think of a household on one day at 11 o'clock in the morning, it has electricity. On another day at 11 o'clock in the morning, it doesn't have electricity. Is it the case that it's more polluted on the day that there's more pollution in its kitchen on the day it doesn't have electricity than on the day it has electricity? That is the question being asked and answered in this regression. I won't go into the econometric technicalities here. So here we're looking at the marginal effect of electricity on induction use in our primary subsample, which remember is those households that own induction stoves and also have a chula, okay, and may or may not have LPG. Okay, so what are these things? So again, time of day on the horizontal axis. And on the vertical axis, we have the marginal effect of the availability of electricity on the probability that an induction stove will be used, right? And what we can see is, again, this morning and evening peak, right? Those are the 2 times a day that these households in rural UP typically cook. People typically cook 2 meals a day, one in the morning, one in the evening. And so you can see that if you have electricity during a cooking time, it's more likely you'll be using the induction stove. Now, this is completely blindingly obvious, but I'm only showing it to you just to show you that the data makes sense. Okay, everything is as it should be. Okay, next one. here's the main result. Now we're interested in the effect of electricity being available on pollution, right? So it's fine, induction stoves may be used, but do they actually substitute for the pollution causing chulas? So it's now again measured in the same way. It's the effect of electricity measured as the share of the hours available on PM 2.5 in micrograms per cubic meter. That's the regression equation. It's similar to the one I showed you before, except now there is a control for outdoor PM 2.5. Okay. And again, all these fixed effects. So here's the result. So you can see, again, now you see the same pattern that you saw previously, but now it's inverted. So during morning and evening cooking hours, if there's electricity compared to there not being electricity, then during the morning peak, PM 2.5 is lower by about 60 micrograms per cubic meter in the hour from 7 to 8 in the morning. And in the evening, it's lower by about 40 micrograms per cubic meter from 6 to 7 in the evening, right? If electricity is available compared to it's not being available. That's the way to read this diagram. Okay, so you see this pattern that in the morning and the evening, the availability of electricity reduces PM 2.5. So days on which a household has electricity during the morning or evening cooking hours are days in which that household's kitchen on average has lower PM 2.5. Okay. Now here's a robustness check. Let me see that I have time here, another 10 minutes. So here's the robustness check. So what we do is we do a technique called the lasso. And what the lasso does is it basically, when you do this least squares minimization problem, it adds a penalty term, which is a linear combination of the coefficients. And the idea is that it's basically penalizing having more explanators rather than fewer explanators, right? And so it drops variables that fail to contribute much to predicting the dependent variable. So what do we do? If we look at the lasso results in the primary subsample, we find that all the electricity shares with statistically significant coefficients are selected for inclusion by the lasso estimator, except those at 6 a.m. and noon, which are not cooking times. Okay, so our results are basically robust in the sense that, you know, of course, because what we did is we have 17 periods in the day because we clubbed together a few of the hours that were not so interesting. And therefore you can, by chance, get statistical significance when you do lots of hypothesis tests, of course, right? So here we just want to check that that's not arising by chance. So use the lasso technique for that. And also coefficient estimates from the model estimated by least squares after dropping the non-selected coefficients are almost identical to those from the original model. So we don't really lose anything here. So the conclusion is at least it passes this particular robustness test. Now let me show you the subsample with only clean stoves. So here we don't expect an effect on PM 2.5 because there aren't any chulas in the kitchens, right? And sure enough, we don't see this pronounced dip in the morning and dip in the evening that we saw in the main subsample, right? And when we do the robustness check with the lasso for this subsample, those households that don't have chulas, we find that all the electricity shares are dropped from the model. They have no predictive power. Okay. All right. So here's now, let me turn to the next robustness check. Okay. And this is oh, wait a minute. Why didn't I should have shown you the control group as well. Did I skip that slide? Yeah, here, sorry, second placebo. So this is again, now it's a different sample. Again, we're looking at the effect of electricity on PM 2.5. Now this is the sample that doesn't have induction stoves, right? So having electricity as opposed days with electricity just to days without electricity shouldn't matter to these households. And we don't see much of an effect here in terms of a morning dip. So 7 in the morning, which was the main dip in the main thing, there's nothing much going on. Similarly, 8 o'clock, something here at 9, 1 or 2 things here. But if we look at the lasso results, all the electricity shares are dropped when the lasso estimator is used. So, even though there is statistical significance in 1 or 2 places, it's not robust. Okay. So now let me turn to our second main question, which is directly estimating the impact of using induction stoves on kitchen PM 2.5. We have a similar equation as before, except that now on the right-hand side, we have the share of the hour that induction stoves are actually used, okay? And we have a second equation in which we predict induction stove use using the electricity shares, right? So this is an instrumental variable technique. We're doing essentially the same thing as we did before, okay? So here's the result. I just will take another 2 or 3 minutes to finish off. The result here is that you look at every time of day and you see whether on a day that induction stoves are used compared to a day that induction stoves are not used, what is the impact on PM 2.5? Again, you see there's a dip in the morning, a dip in the evening in PM 2.5, but if you look at the size of the dip, look at what's on the vertical axis, you see that it's about 10 times as big as the size of the dips that you saw when you were looking at the effect of electricity, right? The effect of actually using the induction stove is in the hundreds of micrograms per cubic meter, okay, on kitchen PM 2.5, controlling for outdoor PM 2.5, right? And where the induction stove use is predicted using the availability of electricity. Okay, so under what conditions is this true? Well, there's an exclusion restriction, of course, and that is that the only channel through which electricity can affect the residual variation in PM 2.5, left unexplained after accounting for the fixed effects and the effect of ambient PM 2.5, is via induction stove use. So what is the evidence in support of the exclusion restriction? One is that we can look at the placebo households, the ones without induction stoves. We find that I showed you this, electricity shares at various hours of the day are not good predictors of PM 2.5 in that sample, although they are in the primary sample. So that would suggest that other channels like use of portable electric fans that could disperse kitchen smoke is probably not significant. We also looked at another possible channel, which is effect of using kerosene lamps when the electricity fails for lighting. But we find that the effect of electricity on kitchen PM 2.5 looks very similar in groups, households with kerosene lamps and those without, suggesting that that's not a significant channel. Here's the effect. Here's the comparison for kerosene lamps. On the left is households that have kerosene lamps. On the right are households with kerosene lamps. You can see that they don't look any different. So really, kerosene lamps are not driving this result. Okay. So the effect I showed you was hundreds of micrograms per cubic meter of induction stove use on PM 2.5, and you can see that that's the order of magnitude of these peaks, right? So the effects are really large enough to eliminate the peaks if you can get consistent induction stove use, which is a tall order, but then it's a hypothetical. So finally, that's pretty much what I had to say. Let me just summarize. What have I shown you? Well, we have very extensive data. It's actually unprecedented data. Nobody has ever collected such detailed data on so many households in the field for such a long time. Most previous studies basically use monitors that monitor the kitchen for 24 hours, right? We are monitoring the kitchen for a year, and we have data at the 1-minute resolution. So what do we find? Well, we find something which is not surprising to anybody who knows something about this. Indoor and outdoor PM 2.5 exceeds WHO guidelines all the time. Okay, that's not surprising. Now, second point is that electricity increases the probability of induction use by 7 to 10 percentage points. Okay, that is, as I said, comparing days you have electricity to days without, that is the effect during cooking hours. The availability of electricity, again, within households across days at the same time of day during cooking hours reduces PM 2.5 quite a lot, by 40 to 60 micrograms per cubic meter. And induction stove use reduces kitchen PM 2.5 by 200 to 600 micrograms per cubic meter during peak times. So those are our main results. So what are some of the larger takeaways from the study? It's a very micro study. It's a very detailed study of a small set of households in a kind of central area of concern for all of us, which is rural UP. First point, induction ownership in rural northern India is presently negligible. 1 in 1,000 households, that order of magnitude. In rural areas, somewhat higher in urban areas. This is not true everywhere. If you look at the two southern states, Kerala and Tamil Nadu, the extreme southern states, they've had better electricity supply for a long time. There they have much, much higher induction stove ownership, right? There is a potential for big effects on kitchen air quality, which is where very high exposure to pollution is, with very damaging health effects. It will obviously also have a big impact on outdoor air quality because of this kitchen smoke goes outdoors. It sort of diffuses immediately, right? Now, what we find is that improving the electricity supply clearly causes those households that have induction stoves to use them more and to substitute for chullas. So improving the electricity supply will clearly do something. There's also the extensive margin, which is very important, that we didn't look at in our study, which is that it's likely to induce households to buy more induction stoves, more households to buy these induction stoves to begin with. One point which I didn't mention is that during the period of study, in these households, there was no metering of electricity supply. So households paid a flat monthly charge of about 330 rupees a month for having an electricity connection. But once they had it, then they could use it in unlimited amount in theory. In practice, of course, the power is not there a lot of the time. So one thing that you want to do is you want to subsidize poor households so that their first something like 60 units a month would probably be sufficient, should be free, right? Or it should be reimbursed by the government, ideally, so that they don't feel that using the induction stove is going to be a big cost. Okay, that would deter usage. So these are some of the, I think, takeaways. And we also need more studies, which I'm also planning to do, looking at the extensive margin. Okay, well, the identification issues will be more formidable there as compared to the intensive margin here. All right, so I just want to acknowledge lots of people who made this study possible. There was a grant from the EFT, the Environment for Development Initiative. Sample households cooperated with us. The Dharma Life provided us data. Prayas gave us data. The National Physical Laboratory helped calibrate the air quality monitors, and several individuals helped us with the equipment and with data collection. So thank you.
Well, thank you very much. That's absolutely clear, first rate study, firm conclusions. And before I open the floor, I wondered, what about relative costs of LPG and electricity, and whether the LPG emissions would be higher for whatever reason than the electric stove? Because we hear very little about electric stoves in this context. I mean, there's been no great publicity, no great government interest, whereas the LPG is, talked about, and great claims have been made for its success, although there are others who point out that the cost of LPG has been steadily rising, and so therefore after the first 1 or 2 cylinders, people who have the connection, who have gas stoves, are reverting to chulas. So some reflections on that before we have others chip in.
Yeah, so, what I think is that it's not an either or issue. It's not either LPG or electric cooking. That in practice, it's going to be a mix of both, at least for a long time to come, many years to come. Because the fact is, we have a large LPG infrastructure. We're building out a natural gas infrastructure, which has reached a lot of people in the cities already. But if you come to my kitchen, and I'm sure if I go to your kitchen, we'll find that we are not using gas exclusively. I use electricity for cooking in addition to gas, right? I have a microwave oven, I have an electric kettle, I have an oven, regular baking oven. I don't have an induction stove in my kitchen, right? But the point is that these sort of things in any kitchen, you will find, typically modern kitchen, you will find, you won't find only one cooking device typically, unless you're a student living in a hostel. If it's a family, you'll typically find more than one cooking device. And I think that's the way things are going to evolve. So I think that the gas, whether it's pipe gas or LPG, will be here for some time to come, because the infrastructure is there, people are used to it. As the electricity supply improves, then you'll get more and more electric cooking. I think that's what we're going to see. Now, when we turn to rural areas, the fact is that right now there are really, by and large, for most households, only 2 options. There's the traditional chula, and there is LPG. And the LPG is expensive, right? So it's more convenient, it's quicker, but it's expensive. Now, what I think the role of electric cooking here is just to give one more option. Just give one more option. It will make life easier for a lot of people, and it will reduce pollution. Now, but we shouldn't expect miracles. What our data shows is that it definitely has an effect, right? And it's a substantial effect. It's not a small effect, but it's far from enough to eliminate air pollution. That's going to take a long time. Habits don't change overnight, So, but it's going to be, I think, a contributor to a solution. And its enormous advantage is basically the fact that everybody now has an electricity connection. 98% of households in India now, that electricity connection is a sort of frail and pretty unreliable one for a lot of households. It can't take much of a load. And there'll be a lot of infrastructure upgradation necessary. But still, I think the point is that it can help. And for poorer households, the electricity is going to be a cheaper option, right? Even if they don't get any government subsidy, which they should, logically, it's going to be cheaper for the government to subsidize the electricity than it is to subsidize the LPG.
All right, thank you. Any comments, questions from our audience?
So here's the question for Somanathan. Rural households even in Sultanpur would not be eating only rice. They would need some way to cook rotis. So either a chula or a gas connection is not going away anytime soon, unless they change their food habits. So one reason why Tamil Nadu people can use induction cooker, other than having better electricity supply, is that they are cooking rice, which can be cooked on an induction stove, whereas rotis are not easy to cook on an induction stove.
Well, yeah, I think that's a good point. So actually, I didn't show you that graph. We do have some data from our household surveys of what people say they use different cooking technologies to cook, what different items. And what we find is, with regard to chapatis, rotis in particular, is that people, these households who have induction stoves, many of them say that they do use the induction stoves to make rotis. However, many more of them say they use their induction stoves to make vegetables and rice. So definitely induction stoves are not a preferred option for making rotis. This doesn't mean that you can't make rotis on induction stoves. You can. I have done it myself. I have on occasion lived in apartments in the US which had only induction cooktops, and yeah, you can make chapatis. I've done it myself. It's really not that difficult. But of course, it's not a preferred option in our data. That's quite clear. So I think, though, what I should say is that that's only to be expected. People are going to have different tastes. They're going to have different habits. These things will change over time with exposure to new technologies. But they're not going to change overnight. They're going to take time to change. My guess is that even if you look at a lot of the stacking that goes on, right? Forget about induction stoves. Just look at LPG and chulas. I haven't examined these data carefully. I don't know whether a study of this has been done, but I would have a strong suspicion that if you look at households in which the cooking is done by younger women, you'll find more use of LPG. And if you look at households in which the cooking is done by older women or people, you'll find much more use of chulas. And that's natural, right? You learn to do things a certain way. You're comfortable doing it that way. You learn to do things in the modern way. You really don't want to do it the old way. It's difficult. So that will take time to change.
So that's an interesting result. You should present it. That it takes, there is a generational change.
No, I don't have that result. I'm speculating. But yes, it's possible to look at data to look for that result. I suspect we would find it if we did look. Yeah.
Okay, I had a question, Professor Somanathan. So I'm Shubhashish. I teach at JSGP. So my question is, one of the advantages of what you're doing is because you're so micro-focused, you're able to generate so many observations. But then along the way, of course, I guess what's happening is we don't see other levels of analysis interact. So for example, there are neighborhood effects on household choices. There could be effects of higher level variables, right? So I'm thinking about this in terms of a sort of a multi-level framework. Now, obviously, you're dispensing with that here, but if you were to have those things, what sort of variables do you think at other levels might affect these choices?
Well, yeah, as an economist, right, I think clearly the two most important things are going to be price and availability, right? Availability is number one. If you have reliable electricity, you're more likely to use electric cooking. Number two, if it's expensive, you're less likely to use it. These are going to be the two dominant things. Then I think on top of that, there is going to be things like, the kind of cuisine, the kind of devices that you will use. For example, let me just give you an example. Bhutan, for example. Bhutan is a country with very good electricity supply, which dramatically improved in the last 20 years. So vast expansion of rural electricity supply to the rural areas in Bhutan in the last 20 years. Now there are 3 rounds. There's been a 4th round recently, but I haven't seen the data of Bhutan Living Standards Survey, in which you can track this, and what you see is a huge rise in the proportion of households that are using electricity to cook. By the way, they're not using induction stoves by and large. Those are not the popular devices. Popular devices are rice cookers and curry cookers. You plug them in and it sort of cooks slowly over the day. You can also have faster ones which cook quickly, electric pressure cookers, basically. But that's what's going on. And now what you see is that, it's pretty near universal now that almost every household is cooking with electricity. That doesn't mean they have stopped using firewood. They still use firewood, many of them, not all of them. Some of them have transited completely to electricity. But there is still quite a lot of dual use going on. So I think my point is that these things change over time, but the changes can be quite big. Now, Bhutan is very fortunately placed, has a lot of cheap hydropower. It exports 85% of its electricity to India. So it doesn't have any shortages. It was just a matter of building out the electricity lines to get to all the villages. That's all it was. They have abundant power and the power is cheap. It's, I think, 1 rupee a unit or something is what they're charging rural households. So really cheap. And you can see massive uptake, right? So I think the point is that things are going to differ according to tastes, cooking types, and Bhutan is not a roti country, it's a rice country by and large. So you would see a different set of devices. By the way, rice cookers are also quite popular in Tamil Nadu, by the way. I didn't give you those data, I just mentioned the stuff about induction stoves.
Could there be a sort of variable set, say I'm just thinking of a level higher, maybe at the neighborhood level or at the panchayat level, that might have any impact on these choices?
Not quite sure what you mean in the sense of neighborhood effects, meaning other people are doing something, so I start doing
yes, that kind of stuff, yes.
Yeah, I mean, I would expect to see that everywhere, right? And that is true with any technology, whether it's washing machines or it's mobile phones or anything new that comes. How do you learn about it? I mean, yeah, some of us might be very good at Google or whatever, but mostly before we actually set out, put out a large sum of money, we want to know whether our neighbors have done it. And whether they have a good experience. So yeah, I think those effects are going to happen, but that happens. I think there's nothing special about this particular technology here. That would happen for any new good or any new piece of equipment.
Okay. You have another question on the there's a long question in the chat box. Maybe Neha Thureja, can you please ask the question? I think.
Yes, sir. Thank you, sir. Thank you for such a clear presentation. I have a question. And so while this was a quantitative study, I wanted to address this fact that when we do qualitative studies, so I've done some human interest stories in villages of Ranchi and Punjab, so in Ludhiana. So there is this belief system that certain local dishes, like in Ranchi, where we have this litti chokha, and in Punjab, when we talk about the makkai roti, and so they often prefer to use chula even if they have the induction stoves or even if they have those LPG connections. So how do we address these traditional values and belief system even when we tell them that you should adopt these methods while you have these methods already? Why don't you use that? But there is this belief system that they intend to use chula for certain traditional dishes, local dishes of the state, of the region.
Yeah, I mean, I would take a pragmatic approach. I think the thing to do is to make the new technologies widely available, to make it cheap, make the electricity reliable. People will adopt electric cooking. They will still use their old traditional techniques, and that's fine. But I think over time, convenience, familiarity, learning how to do it with a new technology, over time, I think these things will tend to take over, and so you will get this happening. So I'm not in favor of kind of trying to propagandize people to stop doing what they have always done. I'm not an enthusiast of that kind of thing. I'm an enthusiast of making the new available and let people do figure things out for themselves. I think we should inform people and educate them that household smoke does have bad health effects. It has very serious health effects. It it kills people. That kind of education is very important. But after that, let people make their own choices. And I think things will change over time. I mean, it's not only Punjab, as you point out, or Jharkhand. In Kerala, for example, there is a strong belief in many areas that rice tastes better if it's cooked on a wood fire rather than on gas. I have been in Kerala and many people have told me this. And yet, look at Kerala, over time, much less firewood, much more gas.
Thank you,
and
sir.
induction, also induction.
Thank you so much.
Well, thank you. I think we've come to time. So thank you very much for an absolutely clear talk. And when we have students on campus, I'll make amends for that you haven't visited our campus. So we'll have you visit us, and we would like to make up with some double time interaction with you and our students. And I hope that you'll enjoy that. We look forward to that. So thank you very much for taking time off from the other conference which you're involved in, and giving us the benefit of this very clear, useful presentation. And it kind of inspires us to, to place reliance on these techniques, and confirming there's a tendency for people to just say, oh, well, that's common sense. But I think it's important not to just rest at that, but to actually, in some scientific way, establish propositions of the kind that you have done. And that's very important for policy. So thank you very much.
Thank you very much. I really enjoyed it, and the opportunity to interact with your faculty and students, and I hope to do so much more in future. Thank you. Thank you for inviting me.
Thank you. Thank you.
Thank you. Thank you, Subhashish. Thank you again. That went off well, I thought.
Yes, absolutely. Good stuff.